Welcome to Algebra 2, Semester 1. We're going to start with a Unit 1 overview. This just kind of covers some of the concepts that you might see throughout this unit, and it really only kind of skims the surface. So hopefully if there's a concept you don't understand when you go through that particular section, maybe it'll make a little more sense the second time around. We're going to begin with concept number 1, coefficient versus term versus factor. Coefficient is the definition of that is really just a number sitting in front of each variable, telling me that there's two x's right here. That way I don't have to go x plus x. So the number sitting in front of a variable called a coefficient. A term is an entire term that's always separated by a plus or minus sign. So if I have 2x plus 5x plus 3x, well, the 2x is a term, the 5x would be a term, the 3x would be a term. Factor is when you have one of those terms kind of broken down as much as it possibly could be. Yeah, I could totally distribute this and have 3y plus 3. But when I have this right here, this broken down, then like this y plus 1, this would be a factor because it could then be kind of put back together. So that's one of the first concepts, kind of knowing the difference between these three. Concept number 2, give you an equation, kind of which one of these could help represent 13x plus 9y. A bus with 13 men and 9 women. See, this doesn't really quite work because that's really just 22 people on the bus. The x and y don't really have anything to do with it. Total cost of 13 of toy y and 9 of toy x. Well, the problem is 13 goes with x and 9 goes with y. So why do I have 13 of y and 9 of x? That doesn't make sense either. The total time of 13 of activity x and 9 of activity y. And x and y, it doesn't even matter what it is, but 13 goes with x and 9 goes with y. I mean, men and women could have worked if it's, adding some sort of other kind of variable to it. Just having 13 men and 9 women, that's 22 people, but 13 of activity x. So maybe x is doing 10 push-ups and y is doing 10 sit-ups or whatever. So then I could, or 20 sit-ups. So then I know x is 10 and y is 20, and maybe it could work out that way. So that's the second concept. Third concept talks about like terms. And with like terms, you kind of want to have what I like to call the same last name. So the numbers in front don't matter. It's all about the variables behind. As long as the variables match 2x and 3x, well, they both have x. If I combine them to make 5x. Now, I'm not making x squared because I'm really just combining 2 bananas and 3 bananas to make 5 bananas, not 5 bananas squared. If one of my terms, remember these are just terms, perhaps there's a plus or minus sign in between. If one of my terms is negative, when I combine, well, same signs, add and keep, different signs, subtract and keep the sign of the larger one. You'll always be exact if you know that rhyme. 7y and negative 5y, well, 7 minus 5 is 2, and again, we're not making y squared, we're just making y. 4xy squared and 10xy squared. Well, as long as xy squared matches xy squared and this isn't somewhere else, then 4 and 10 make 14, and I just make xy squared. 6x and 9y. Well, this says x and this says y. This is 6 bananas, this is 9 apples. I really just have 6 bananas and 9 apples. I don't really have 15 of anything. I mean, you can call them 15 fruit, but fruit is not represented by one of these variables. So if I'm asked to simplify, I just got to find these like terms. I'm not even solving all the way. Find the terms that are the same, whether they are both variables or perhaps 2 numbers. If I had plus 4 and then plus 6, the 4 and 6 would be combined. Because not having a variable makes you the same. So 2 minus 7 becomes negative 5, and that's how you simplify it. With an inequality, which we'll see a lot of, inequalities, we're going to treat them mostly as equal signs until we are ready to kind of take the next step. So I just combine what I see on one side of my inequality, just like I would on one side of my equal sign. I'm not going to worry about anything over here, combining like terms, if there happens to be something that shows up. That goes when we start solving equations. I just want to simplify this one side. That's why I said simplify, not solve. Simplify this one side and get it to that. So that's concept number 3. Concept number 4. They're giving you an equation. They're solving it for you. And they're giving you these properties, kind of explaining what's going on. So I'll just let you read this one and kind of see when we add to both sides, when this becomes 0, that's the additive inverse property. When this side becomes this and 0 kind of disappears, that's our additive identity property. When I divide both sides, division property, and we finally get our answer. So that's concept number 4, just kind of making sure you know not just how to do it, but what kind of property you're working with and how they kind of interact a little bit differently. No solution versus infinite solution. This is concept number 5. Basically, you have an equation, and if I have a value for x, and I plug it in, if I have 3 times 5 and 3 times 5 plus 1, well, there's no way that these are going to end up being equal like it says it's supposed to. And if I want to solve this like an equation, well, I want to move this to the other side by subtracting. No, my variables are gone completely, and I have 0 equals 1. Well, that is a false statement. There is no solution for x that I could plug in to make a true statement. For infinite solutions, it's kind of the same way, except every value for x that I can plug in will actually give me the right answer. 2 plus 3 and 2 plus 3, negative 7 plus 3 and negative 7 plus 3, 4.17 plus 3 and 4.17 plus 3. I'm always going to get whatever equals the exact same thing, so I'm doing the same thing. And when you do it by solving, and I subtract my variables, I have 3 equals 3. Well, that is a true statement with no variables in the mix. That means we have, infinite solutions. Make sure I'm still recording. I'm sorry, this is probably going to be a long video. Number of solutions. If it asks how many solutions, basically you look for the exponent. That'll tell you usually the maximum number of solutions you can have. So with an invisible exponent of 1, we can only really have 1 solution, unless, of course, it's infinite or no solution. X squared means I can actually have 2 solutions. They may be the same solution twice. They may be 2 different ones. X cubed, kind of the same way. We're going to have 3 solutions. X to the 4th, we could have up to 4 solutions. Maybe some of them are the same ones twice, perhaps. That's concept 5. Concept 6, we're trying to solve for x with x already being squared. When you have x squared and you need x by itself, squared is kind of counterbalanced by square root. So to solve for x, you just square root both sides, and x is 7. But when you square root both sides, you got to understand that both the positive and negative versions of 7 actually work here. And when we plug in 7, and 7 squared is 49, but negative 7 squared, negative times negative is also positive 49. So that's why we have x is actually plus or minus 7. And sometimes they write it plus or minus, or they'll say x equals 7 and x equals negative 7, or x equals negative 7. When you have x squared equals a negative number and you square root, we actually cannot find a real answer to go here. This would be like a no solution type, because if you come over here, if I plug in a positive number, I get a positive number. If I plug in a negative number, I get a positive number. Either way I do it, it's gonna come out positive. So in order to get this negative number, it's actually not possible until we get to the complex numbers later on. So on this one, it would be like a no solution type answer. So that's concept 6. Concept 7, write an equation given a story. And you just got to understand $15 per hour and $15 per ticket. Well, which one do I really need? Which one is the 15x? Well, it just kind of depends on the situation. Perhaps y needs to be the total cost of people getting in a theme park, and it's $15 per ticket plus $10 parking or something like that. Maybe Y is your total take-home money, where you made $15 an hour for X amount of hours, and on the other one it was X number of people get into the park, so X number of hours plus a $10 tip that a customer gave you or whatever. With sibling ages, when you write these, you just got to understand, if Tony is 3 times Becky's age, you can do Tony equals Becky times 3, 3B, which means Becky plus Tony, which is 3 Beckys, is our total age. So that would just be a grand total of 4B. But if we need Tony plus Becky, we wouldn't just write B plus T. That doesn't get us anywhere. So you would write it kind of more with, well, I know Tony is 3 times Becky, so we'll just use 3 times Becky in place of what would have been Tony. So that's concept 7.